pleasure to introduce Professor Craig Zilles of the Siebel School of Computer and Data Science at the University of Illinois at Urbana-Champaign. Excuse me. I see from Craig's bio that in 2010, he received the McVan Valkenburg Early Career Teaching Award, as well as an SF Career Award. And he has conducted research on both compilers and computer architecture in the past, and more recently on computer-based testing and applying computing and data analytics to education. So he's got a very interesting talk today to tell us about how he uses computer-based testing to support the computing program, I would assume, at UIUC. I'm really looking forward to hearing the lessons learned.
Yep. Yeah, and it's not just the computing program that's supported by this. I'll show you some data later, but it's widely used across many STEM courses, mostly lower level courses. So yeah, I'm Craig Zilles. My background is I don't know, it's kind of weird. I started as a mechanical engineer and got my PhD in computer science and did research in sort of core CS. And then after getting tenure, I was like, oh, I'm actually really interested in all the scaling challenges we're having as our department's getting larger and larger. And so I shifted my research completely to focus on the interaction of computing and education. And so I'm going to say a bunch of stuff. I have a lot of stuff to say, but you are encouraged to interrupt and at any point be like, wait, that doesn't make sense. How do you handle X? Or, what about this? It's more fun for me and for people online. Michelle will be watching the chat and she can relay the questions to me. And if for people online, if it gets trouble hearing me, let Michelle know and she'll encourage me to move back towards where the microphone is. All right. So there's three things that I'm going to try to communicate in this talk. The first is that we can increase student learning and reduce student test anxiety. And I'm going to show you two ways of doing that: frequent testing and second chance testing, which is basically offering students a retake opportunity on tests. And I'll explain sort of the mechanism why that helps student learning. The key to this, though, is it makes us have to offer more tests in order to do this. And it would be nice if we could do that just online, but sadly we can't. And I'll show you some data on what I call a phenomenon called learning to cheat. And I'll explain that by what's called the fraud triangle theory, which I think is useful for thinking about cheating. And lastly, I'll talk about our computer-based testing facility, which I think is a proven means of both securely and frequently assessing students with low effort. So it's sort of like this is the why and this is the how. So again, stop me at any time. I know you aren't mostly not an education-oriented audience, so I'm going to introduce one definition, which is when we think about assessment, there's two kinds of assessments. There's formative, which is for giving feedback to learners, which is primarily things like homework and practice exams, so people know how well they're doing and what things they're not understanding. And then summative assessment, which is what we use for assigning grades. This is evaluating what's been learned. So typically things like exams or final projects are summative assessment. And so I have a few premises that I'm going to sort of state as things that I believe to be true that sort of are the foundation for what I'm going to show you, which if you want to question them, we can, but mostly I'm sort of stating them as axioms, that we need to assign grades, so we need to do summative assessment. And I'm going to focus mostly talking about summative assessment. Assessments also help learning. So both motivationally, that knowing that there's an exam causes students to practice things, and mechanically, the act of practicing, there's a lot of data in education that suggests the way that you get things into your long-term memory is you do what's called retrieval practice, the testing effect. You try to apply your knowledge to situations and doing that in a spaced manner. So doing it now and then doing it 2 weeks from now and then 2 weeks from now is what causes people to learn things. And so it's good if we can design assessments to take advantage of that. Gen AI makes it hard to trust anything without knowing its provenance. That I think trying to guess whether a student artifact was generated using AI or not is a losing battle. That I think it's hard to do now, basically impossible now. It's going to get even harder. And so provenance is a word that means we can track how it got to us. And so that proctored exams can be trusted because we can know the provenance, that we can watch the student generate the artifact and know what they have available and know how it got to us. I don't think proctored exams are the solution to everything, but I think they have a useful role, especially in the world we find ourselves right now. Lastly, I'm going to show you data from CS courses, but my belief is that these findings are generalizable beyond just CS. So, part one of the talk is that the structure for exams shapes student behaviors. My colleague in physics has a saying, students are a lot like people. And what we know about people is that they will procrastinate. And so what I'm going to show you is that if you test infrequently, that encourages procrastination and last minute cramming. In contrast, if you can do frequent testing, that encourages students to learn the material as it's introduced and to do more studying in aggregate. And I'll show you data that supports both of these. These in turn lead to higher exam performance, which is a proxy for better understanding and lower test anxiety. Yeah.
Is the lower anxiety mainly about so many assessments that you do bad and one hasn't killed yourself?
So my perception is that what creates anxiety is that there's a single event that has a large impact on their grade. And so if you go in, if you have a, one midterm that's worth 25% of their grade, they're much more freaked out than if they have 5 midterms that are each worth 5% of their grade. So that's the main effect there. Yeah. Yep. Great question. Other questions? All right. So there's been a lot of work in frequent testing, and so I'm going to try to summarize what the previous literature has shown. The first is there's a large benefit on a final exam score from adding the first midterm. So if you go from 0 midterms to 1 midterm, you get a big benefit on the final exam. If you add additional midterms, you get diminishing returns. So that makes sense. So that's if you're changing the amount of midterms. If you're keeping the amount of midterm content constant, but if you're cutting that into more smaller pieces, they will do better on each of the pieces. So that's explainable by multiple mechanisms. One of is, it's just easier to cram a smaller amount of material. So that's one thing. But so the thing that we care about actually is not how well they do on the midterms. It's how well they do on the final exam, or which is if you have a comprehensive final, that represents maybe some retention of that material. And the data is somewhat mixed about whether more smaller exams lead to better final exam performance. Some studies find that it does, and other studies find that it doesn't. My hypothesis of why that is that I think our classes have a range. There's a continuum of how cumulative the content in a class is. So I'll show you some data from a CS1 class. A CS1 class, the content is very cumulative. Every week of material depends on everything that you've learned up to that point. And so in that context, we see more impact on the final exam. We see a benefit on the final exam. Alternatively, some classes are sort of topics classes. So my machine organization class is a good example of that we teach them digital logic, and then we teach them how a computer works, and then we teach them MIPS assembly, and then we teach them pipelining, and then we teach them caching. And these are like kind of topics that you can learn independently. And my guess is it's those courses where you're doing a bunch of different stuff where, cutting into smaller pieces doesn't necessarily have as much impact on the final exam. All right. So, yeah.
So there's this, as we said this a minute ago, really relates to the last point. There's a benefit of delayed testing. Right? If the testing is immediately after, then it sort of loses the information very quickly afterward. So if you're cutting into little pieces, especially in the non-cumulative kinds of courses, then you spend a week on something, you test it, and then you don't see it again. So in that, would there be a benefit then, even if there are lots of small exams, to have each exam include material from the
Yeah. So I think that's exactly, the right thing that you need to create the spaced retrieval practice if it's not built into the class, because the class is so cumulative. So that my recommendation would be have a comprehensive final at the end so that you're messaging your students, you can't learn it and forget it. And then exactly what you're saying, that, having like 80% of the material on a given exam be new material, but 20% being a review of stuff you've done before encourages them to do that spaced retrieval practice. Yep.
more of a comment. I encountered this about 10 years ago when one of my family members went to medical school.
Mhm.
This is exactly how they do it. Every 2 weeks or 3 weeks, they have a test that tests what they have learned in a particular course until that point.
Okay.
And it's a lot of cumulative knowledge.
Yeah.
That they just keep testing.
They just keep banging on it. Yeah, that again, yeah, repeated retrieval practice. So there's very little data about the mechanisms, like why these things are happening. And so I'm going to try to show you some data why I think they're happening. Frequent testing is also associated in general with the literature with low anxiety and also higher course rating. So if you don't actually care about your students, but you just want good student evaluations, then do some of these things also. Yep.
Said what we care about is final exam. Does
Well-
that mean the final exam has?
So I think what we care about is 2 years after they take the course, do they remember anything from the course? That is just a pain in the behind to study. But so I think a final exam performance is a better proxy than the midterm performances of like, did they learn something? But go ahead and finish your question.
Weight of the final exam. How do we,
What's the weight?
the weight, yeah. If the final exam is important and we care about it a lot, there should be some heavy weight on it, but that increases anxiety.
Yeah, so I think there's a trade-off there. I think, and one of the things that we invoke multiple times is humans aren't rational, and that so I'm a huge fan of behavioral economics, and one of the things that's known in behavioral economics is we overvalue small things and we undervalue big things. So for example, people will buy lottery tickets overestimating their chances of winning the lottery. And so I think you don't have to make the weight of the final exam to be huge in order for students to think that it's large. That if it's large relative to the midterms, they will think it's large, but it may be less stressful, if it's like a 15% final than a, 35% final or something like that. Does that make sense? Sort of? Yeah, question in the back?
Right. Distributing the formative assessments interstate on real to reduce stress. And I think these different strategies allow students to take online computer-based tests, several tries.
Yeah, and so the question is, have we tried several tries? And that's the second thing I'm going to talk about. So first, going to talk about frequent testing, and then I'm going to talk about retry exams. And I think both are good, and it just means even more testing. Some of it being optional. All right, so I'm going to show you some of my data. So this is collected from a CS1 from non-technical majors. We have 3 CS1s that our campus offers. This is the gentlest of them, the one that's required by the College of Business. To give you an idea, semester-long course, but it doesn't actually get to either recursion or object oriented programming. So you can get a sense, but it's taught at about 600 students per semester, which is good because it means we get a lot of data. So I'm doing what's called a quasi-experimental design, which means I'm comparing 2 semesters against each other. So it's not a randomized control trial, so interpret it as such. Everything is the same in the 2 semesters except for the exam regimen. Both of them have an exam 0. So in the 3rd week of the class, this is in part because they're taking exams in our computer-based testing facility. And for students that have never done that before, we have this exam that's worth only 2% of their grade. That's pretty easy. That just gets them acclimated to taking tests in that form. And then the rest of the semester is different. So we're comparing a baseline semester, which has 1 midterm that's worth 20% of the grade and 1 final that's worth 30% of the grade, to a semester where we do more frequent testing, where we take this midterm and this 20% midterm, we crack into 2 10% midterms. We're going to call exam 1 and exam 2. And then this 30% final, we're going to crack into a 10% midterm called exam 3 and a 20% final that's called exam 4. Question? Same instructor, me both times. Yeah. And this course, because there's no courses that depend on it directly, we get roughly the same student population both fall and spring. And we'll see that they score similarly on exam 0, and what we've seen over semesters, a bunch of semesters, that we get roughly the same grade distribution in fall and spring. So while it is a quasi-experimental design, I think there's definitely information there. In addition, in this frequent testing semester, at the time I ran this study, I couldn't afford to offer them retake exams in the computer-based testing facility because we didn't have enough space at the time. And so I approximated doing something kind of like what he suggested by giving them a online unproctored quiz, which is very much in the same structure as the exams, the week preceding. So they could take this. It was kind of like the goal was, understand, are you doing well or not? And then you have a week to figure it out before the thing that's actually worth a bunch of points. But this is unproctored, this is proctored. They're both 50-minute assessments that are structured very similar. In the infrequent semester, we also gave students an opportunity to self-assess. So every 2 weeks, when there wasn't an exam, they could do something that was very much like one of those quizzes or exams to see how they were doing, but it was purely formative. So there's 0%, impact on the grade. So if they wanted to check how they're doing, they could. Yep.
Tested on exam 0 and how many weeks into the semester?
So exam 0 is third week of the semester. So it's a lot of tracing questions and usually like writing one line of code that does like a mathematical, like here's a mathematical expression written in math notation, write that in programming notation. And so they do very well on it. And mostly, again, it's just to settle their nerves. Yep. I'll show you some data on that. Yeah, it's what you think it is. Not very many.
The self-assessed that comes right before the midterm, which is similar material, right?
Yeah.
Obviously, we got to make up 2 unique tests though.
Sort of. So let me tell you about the exams. So I'll tell you about the computer-based testing facility at the end, but these were run in the computer-based testing facility, and we run exams asynchronously. So students take exams over a 3-day window, which means we can't give everybody the same exam. And so instead we construct the exams by giving them having a bunch of question pools where we draw one question from these 4 questions, but these are actually what we call question generators. So instead of each semester rewriting individual questions, you think, okay, what are all the ways that I could ask this question? And I write a little bit of code, and then I have a question generator that just generates those versions. And so, for example, the value of a conditional expression, this is a tracing question. So we show students a Boolean expression and ask them, does this evaluate to true or false? And we can generate a whole bunch of different Boolean expressions. And so because there's so much randomization on the exam security, like keeping the question secret, is not why we can trust our exams. We trust our exams because they have so much stuff on them that it's harder to memorize all the things than it is just to learn the content. So we basically, once we've got enough content, we typically will just kind of run the same exam semester after semester. And so the exams in both these semesters are the same, that we literally took this exam and we cut it into pieces. And these quizzes actually have a significant overlap with the exams because it's just the same body of, mostly, there's 2 things. One is there's 1 week of material difference between these. So the exams cover a little more material. And we have it's hard to write question generators for things like programming questions. So we will write individual programming questions, and then we'll have larger pools of them. And we have pools of programming questions that only show up on exams that aren't on practice exams or homework, or the quizzes that are unproctored. So there's about a 60% overlap between these 2 things in the question generators. Yeah.
So the fact that this is not paper and pencil, does it affect the kind of questions I asked?
Yeah. So tracing questions, because they can just compute it to figure out, like, we don't put a lot of points on them. Instead, we've created what we call reverse tracing questions, which are a little harder to game. That basically we show you a piece of code and say, what value should X have as an input so that the output is, 250. And so that's a little, they can still sort of brute force try a bunch of things, but then they're wasting a bunch of time. So there's a little bit of that, but mostly that's the main thing. I think, again, we just ask them to write a function that does blah, that kind of thing. And yes, they can test it before they submit it for grading, but I think that's actually a good thing. Yeah.
Haven't done like work on like what if this, how can this translate to a theoretical course?
So let me hold off on that. Let me show you some data and then we can talk about how to apply it. And I'll show you at least one example that sort of applies. All right, so we see what you'd expect to see. Again, cutting a big exam into smaller exams, they do better on each of the pieces. But like this is effectively the final, and that they're doing, the thing is, because CS1 is so cumulative, they're doing a little better on the midterm content, but they're doing a lot better on the final because, I think the history of CS1 having low failure rates was if you sort of got off the tracks, you just sort of kept getting farther and farther off the tracks. And so we're doing a better job of keeping the students on the tracks. So this is sort of like 10,000 foot level and not truly scientific. If we really want to do it scientifically, we do a giant linear regression where we try to predict the student's score by estimating how difficult questions are. And this is the interesting part, estimating how much better they're going to do based on which exam they took it on versus the midterm versus the exam 1 versus exam 2, for example. And if we do that, we see data that looks like this, where for questions that show up on E1 and the midterm, they're doing just a little bit better. But remember that they're taking E1 3 weeks earlier than the midterm. So 3 weeks earlier in the semester, they're doing a little better. At roughly the same point in the semester, they're doing quite a bit better. And similarly for the final, 3 weeks before the final period, they're doing either a little worse, a little better, or about the same. But by the time you get to the same point in the semester, they're doing quite a bit better. So again, this is kind of what we would expect from previous research. But again, it's exciting to me that all I did was ran more exams and they did quite a bit better. So I think what's interesting is why. And so I did a survey. We did this with the majority of students in both semesters, so we have hundreds of students responding to this survey. The first thing is if we ask them, is the number of exams in this course too few or too many? The ones where there are more tests, the students will say there's too many. And I think so there's a saying in education, which is education is the only thing that people want as little for their money as possible. That I think many of you have taught, if you ask your students, should we cover topic X or not? They will say like, no. So I think this question is kind of poorly phrased because if you instead sort of ask, do you want 2 big midterms or many small midterms, they would say many small midterms. But if you sort of say, do you want, more or less, they answer kind of funny. This one I think is more interesting. The difficulty of the exams are, what we see is in the frequent semester, they're reporting that the exams are easier. So again, it's the exact same exam content on average. And they think it's easier because they're doing better. And then I find the quizzes and exams very stressful. Both of them find it pretty stressful. The frequent students find it slightly less stressful in this example. This class is not stressful, but they claim that it is. What?
Like that chart on the far right. I find the quizzes
very stressful. So more of the infrequent semesters say they strongly agree that the class is stressful. So we're shifting some of this mass that way, which means that more people are disagreeing with that statement. Yeah. Less stressful. So, but not as much as you might have hoped. So, what? This is better also. So the difficulty of the exams, more people are saying that they're very easy in the frequent semester.
right. That's why I was a little confusing that.
Yeah, this one doesn't make
sense.
sense.
To shift left.
Yeah.
The last one, it's better to shift right.
Yeah, fair enough. Fair enough. We also interviewed students. When we do interviews, we use a technique called grounded theory, where we go through the interviews and we identify statements that are interesting, and then we cluster those into what are called themes. And what I'm going to show you is some data on some of those themes. And with an example quote from students. So one of the themes was that frequent testing promotes more consistent studying. So this student says, I probably would have been forced into more review and thus a bit more solid understanding in a week-by-week basis. So this was a student that took it in the infrequent semester. They're saying, had I had the frequent testing, I would have been forced to sort of keep up with the material. And what's interesting is when we did a faculty survey about what they thought was interesting about being able to use our computer-based testing facility, the ability to use small frequent tests was one of the things that they valued. And this faculty member said, the CBTF has allowed us to move from a standard three-term midterm model to a weekly quiz model. As a result, students are staying on top of the material better. Students are more participatory in class because they have not fallen behind. So like it was obvious to the instructor that the students were behaving differently, that they kept up with the material better. Another theme was infrequent testing leads to mass practice. So if I only had a midterm and a final, I'd probably just start reviewing the week before. So we see this in the data. So because we have these pools of question generators, we provide the students a practice exam generator. So they can press a button and boom, they get a practice exam. They can press it again, they get another one. And because of that, the number of problems that they do on those practice midterms is a reasonable proxy for how much studying they're doing. And we see that 95% of the studying happens in the 48 hours leading up to the exam. And so, that empirically we can sort of validate that, no matter sort of how big the exam is, you start studying like right before the exam. Again, students' lives are busy and complicated. They have all these things that they're trying to do. And they can't sort of get to your class until it's like truly critical. This is my favorite one. Frequent testing promotes conscientious practice. The student said, had I had frequent exams, when I'm working through zyBooks and stuff, I would have make sure that I'm actually understanding what I'm doing instead of just trying to get the participation points. So we were using a textbook from zyBooks that has activities built in. So when I do a reading assignment, because my class is flipped, I want to make sure that they do the reading before they come to class. And so I give them some small amount of credit for doing the activities in the book. So the student's saying like, that what they were doing was they were just trying to get the points and they're like, okay, I'm going to put off my learning. I have to learn this before the exam, but I don't have to learn it now. And what's interesting is we can see this empirically at the scale of the class. That we worked with zyBooks and they have a statistic that they call earnestness. And there's two kinds of activities in their book. There's multiple choice questions, and an unearnest student is one that just bangs through the multiple choice options until they get the right answer, because getting the wrong answer doesn't have any penalty. And in fact, the low earnestness is if you spend less than a second between getting the wrong answer and getting the right answer. So like there's no think time there. And so what we see is to a 0.001 statistical significance, the students in the frequent semester are being more earnest than the students in the infrequent semester. Similarly, for the short answer questions, these short answer questions have a help system that if you press the help button enough times, you get a show answer button. And so then you can just cut and paste that answer to get the points. And so again, we're seeing, again, at the 0.001 level, the students in the frequent semester being more earnest. They're doing that behavior less. But they're doing, yep. So it is a fill in the blank question, and the way that they can basically, there is a show answer button that gives them the thing that they can cut and paste to fill in the blank.
So what you're saying is for the frequent semester where they have more frequent midterms, what you see in the zyBooks is that they're actually solving the problems themselves more than just like
using the help system. Yep.
Yeah. Until they get
yeah. And so the way I think about this is if my midterm's 4 weeks from now, I can get the points now and convince myself that I'll learn the material later. So humans have this enormous capacity to deceive ourselves. And so it'd be like, oh yeah, I can, I'm busy. I want to go out and have coffee with my friends or whatever. I'll get the points now and then, I'll study later, but then like later never happens. Whereas if the exam is 2 weeks from now, like later is now, like I have to do the thing in order to I can't put it off. So that's how I think about this. So the other piece is the student studying. And so the big takeaway is that the amount of studying you get is sublinear with the grade percentage. And so again, we're looking at how many practice problems this student did on the practice exams before a particular assessment. So this is the 20% midterm. And what you can see is that students on average are doing about 220 practice problems. And so our exams have like 25 questions on them. So they range from everything from like, here's a Boolean expression, does it evaluate to true or false, to write a function that does, X. And so for 20%, they're doing 220. For this 10% midterm, they're doing less. They're doing maybe 170, but it's not proportionally less. It's not half as much. And so if you add the amount of studying for this 10% midterm and this 10% midterm, they're doing roughly 340 questions compared to this 220. So as you cut your things into smaller pieces, you're getting, the amount of studying is sublinear, so you're getting net more studying. And again, the way that I think about this is, if they're not studying before the 48 hours leading up to the event, there's only so much time that they have to study. And so maybe they're going to put a little more of that 48 hours into studying. But if you cut your exams into more pieces, you have more of those 48-hour windows that they can sort of scavenge time to study more. Similarly, for this 30% final, they're studying more than this 20% final. But again, if you add this 10% midterm and the 20% final, you're getting net more studying. Okay, so this is from before ChatGPT. Back before ChatGPT, a bunch of the students took the unproctored assessment seriously. And so this is worth 2%, this is worth 10%. Rationally, you'd think they might study 1/5 as much for this as this, but we're getting about 2/5 as much. So again, sublinear, so more smaller things. But if it's worth 0, so everything I've shown here is studying except for the self-assessments. For the self-assessment, like, why study for the self-assessment? You just can take it as many times as you want. So what we see is at the beginning of the semester, this thing that's worth 0, some students are earnest, but as the semester goes on, there's less and less earnestness. That students their lives get busy, and so if there's no incentive to do this thing, a bunch of them are just not going to do it. So does that answer your question? Yeah. Again, not surprising, but it's nice to have hundreds of students of data to see that. All right.
Yeah, that's maybe that's why they're more than the self-assessment, but you also assign this small weight.
Yeah, and I think it's the grade. And again, this is from before ChatGPT. So I don't think very many students would study for an unproctored assessment now. But I think it was that 2% that, so I think most students want to be honest, but I'll show you some data later about honesty also. Cool. Questions about frequent testing before we move on to second chance testing? Yeah.
So looking at the other side of the aisle, so if there is not, like, it's not computer-based testing, it's like we have human graders and TAs and everyone going in. So this frequent testing does add a lot of things onto the process, because we had this when we were doing like standard-based things, and then we have every week there's a quiz, and every other week there's homework, things like that. Super frequent.
So
Add more burden on the other side of the aisle.
Yeah.
So like, do you have any data for like, would that still, because then the grading also gets delayed, it's not immediate.
Yeah. So I think I can show you some stuff in a second. I think the answer is you think really hard about the things that you can convert into an autogradable format, and you do the things that you can in that format, and that frees up the humans to do the things that can't be auto-graded. So my mantra is like, automate the things that get better with automation. So with these question generators, like having web-based homework is better than paper homework because you get immediate feedback, and we can do mastery where if you get it wrong, you can immediately try another problem. I think the CBTF makes it able to run exams frequent and with second chances and things like that. So it gets better. And that frees up the humans to do the things that, maybe open-ended projects or, things like that you can't automate. Yeah, automation should make our lives better. And the student's life's better, I think, too. So second chance testing. So this is the idea of offering every exam twice. We do it 1 week apart. We give students feedback. They know what their scores, they know which questions they got right and wrong between the exams, so they can go away, study the things that they got wrong, come back. The second chances are optional. This is interesting that you would think that if a student got 100% on the second chance, we should give them 100%. And I agree in theory, but again, these are people and people are funny. So some fraction of the students will skip the first exam and just take the second exam, which, you know, they're just like, great, you gave me a 1 week extension to learn the material. But the problem is, you know, your course has sort of moved on and you expected them to know the stuff, you know, and so what we found is that we need to put some friction that prevents that behavior. So you need some weight on the first exam. We looked at a bunch of policies. What we've concluded is it doesn't really matter exactly what the policy is. You just need just make them think that the first exam is worth something, and then they behave how you want, that they study for the first exam, get the feedback, those that need to take the second exam, you know, with additional study. So one exam of that policy is 90% of your maximum score and 10% of your minimum score. So that's a very close approximation to full replacement, but it sort of elicits the right behavior out of the students. So what we see when we offer second chance testing is reduced failure rates and tightening of the distribution, a reduction of test anxiety, and I'll show you data on both of these, and also increased perception of fairness, that if student has 2 chances and they fail both of them, they kind of recognize that it's them and it's not you. You know, where sometimes where if I run a single exam, people are like, oh, this is hard, you know, like whatever. But, you know, that a lot of that goes away with second chance testing. So second chance testing is an approximation of what's called mastery learning. So this is what I call traditional one-shot testing, which many of us do, which is we sort of run an exam once and then we move on. And so if you're following along, that's great. But if, you know, you struggled with exam 1, too bad, you know, we're moving on to topic B. And if it's like my CS1 course, if you were struggling here, then you start crashing out later on and it's a bad scene. So the gold standard is what's called mastery learning, which basically is if you're struggling, we don't let you continue on to the next thing until you mastered the current thing. And so maybe that'll take you a bunch of attempts and, you know, before you move on to C. So everybody sort of agrees that this is like the right thing to do, except we have these fixed length semesters and cohorts of students. And so it just isn't a good fit for the regular semester. You have a question?
Yeah, so just a quick logistical question. Do you give your exams during the allotted lecture time?
We don't. So we again, we run them asynchronously. We give them a 3-day window. They self-schedule. Yeah.
Oh, you have these special labs.
Yeah.
Okay.
Yeah. Question? So I have very few concerns about leaking examples. My belief is if you have enough exam content, you could put it in the public domain and like, again, like imagine you had an infinite number of questions. Like at some point it's harder to memorize how to do those things. Like, you know, you just need the pool large enough that the rational strategy is to learn the material. And so again, a lot of our question generators, usually about like 70% of our exams is on the practice exams so that the students can like practice the thing that they're going to be tested on. Because like, I'm not trying to test your IQ. I'm trying to test how well you learn the material in my course. And so if there's a lot of randomization and like large pools of stuff, like, again, it's harder to cheat than it is just to learn the material. Yep.
Said, so I do something similar where I had quiz and then some of those, you know, quiz questions later. But my fear is always rate inflation. So even maybe measuring that with performance in the natural sense where they're actually coming from mastery and not from, oh, I've seen that.
Yeah, so we've done some studies where, so again, writing programming problems is hard to write generators. So we typically will write a problem and then we write proliferations of it that are like, oh, we tweak it in some little way so it's a little different problem. So we've run exams where there's a pool that has the problem version that they saw on homework and then ones that they didn't see on homework that were different. And we see roughly like a 10 to 20% benefit of if they get the one that they saw before over the ones that are basically the same content but a little different.
But
Yeah, so again, my question pools are big enough that I think it's a remarkably good proxy. Like, so I think there's an important thing to, so in the AI context, you have this notion of overfitting, like, and so, are the students just overfitting to the material that we're getting there? To what degree can they generalize beyond the specific questions? I think that is a concern, but it's actually a smaller concern than the students learning the material. That I think you're at risk of, if you're just like, I'm not going to tell you anything about my exam, the students are like, I don't know how to study, so I guess I'm not gonna study. I think it's much better to be very clear about what your expectations are and give students, as many practice problems as they want, and they will spend a lot of effort, grinding that to learn the material. And for these sort of lower level building block skills, I think that's exactly what they need to do. I think for later, junior and senior level courses, you want to do more integrative activities. And I think what we're doing here is not necessarily a fit for, assessing that kind of knowledge.
Is that separating the times for that you try, or is there data on not separating times and just simply allow them to try it? Because like, with auto grading, say, allowing multiple attendings, it's the same.
Yeah, so we do roughly a week. I was just at Utah State, and their Calc 1 test class makes them, you can take exams as many times as you want, but at most once a day. I do think it's important to have some think period, because if they're just sort of like blasting exams, like that's not the behavior you want. You want them to say, oh, I didn't understand X, let me go try to understand X and then demonstrate X. So I think it's useful to have some cool down period. I think a day is probably enough. We just did a week because that's what we started with. But I think their model is actually kind of interesting, maybe more so for a math class than a CS class. But yeah, so what we do in second chance testing is basically, instead of serializing these things, we're parallelizing them so that if you don't do well on exam 1, you have to restudy A in parallel with learning B. But compared to this, we're motivating you to go back and learn that material and hopefully master it. And hopefully that means that even if I'm struggling a lot, that I'm passing the class or getting a B, versus in this case where maybe I'm going to get a D or an F. And so this student is doing more work because they're having to relearn A in parallel with learning B than this student is. And so I think, rather than modulating the length of the semester, which we can't, you should modulate how many courses you're taking. So this student that's just sort of gliding through all their classes may be taking 5 or 6 classes, where these students might have to take 3 or 4 in order to succeed. But the thing is, ultimately they're succeeding rather than sort of failing and having to retake a bunch of times.
Find out the
So it depends. So our question generators will tell them the right answer. So after they've used as many attempts as they're allowed to answer the question, if they get it wrong, they get shown the answer. A lot of our coding questions don't, but the students can go to a TA after the exam and have them pull up their exam, and they can talk through it with a TA, like, okay, how should I have answered this question, so on and so forth. Does that make sense?
So question can be here on the retake, right?
So often the programming questions will be different pools, because we don't want, that effect. But the question generators typically won't, that again, it's just, we have a large body of things that you're supposed to know, and you don't know which subset you're going to get tested on at a particular time. Cool. So this is where I think second chance testing works best, is when you have a really hard learning objective. So my belief is that giving students multiple attempts allows you to have high standards and have the students bounce off the standard, realize that they don't understand it, go learn it, come back and demonstrate mastery. So this is a question in my machine organization class where I give them a working Verilog of a single cycle MIPS subset processor. And I say, okay, here's an additional instruction, modify the Verilog so that it doesn't break any of the existing instructions, but it also now supports this new instruction. So that is a hard thing. They have 50 minutes to do that one thing. Many of them can't do it when they try the first time, but that is the incentive they need to go and figure out how to do it and come and demonstrate mastery on that. So on individual hard learning objectives, we see this kind of thing where, maybe 30% of the students will retake it. And then if you aggregate that over the whole semester, what you see is a tightening of the distribution. So overlaid are two distributions. There's a yellow here, which the purple is the overlap of the blue and yellow. So we had one distribution, the yellow distribution, which was after their first chance attempts. And then the blue distribution is after the second chance attempt. So what you see is a narrowing of the distribution. That in particular, this yellow tail is being absorbed into the blue. And some of the, the B students are now, A students, which is great, but I'm more concerned about, this tail, in particular, this big block of students that, was getting sort of, C level, or maybe D level is now getting sort of C level stuff. It doesn't save everybody. There's still some students that, if you get mono and your grandmother dies and your dog divorces you all in the same semester, like, that happens to some students, and this isn't going to fix that problem. All right. We ask students, do they like it? They like it. I view retake tests positively. I wish more of my courses would offer retake tests. They both are very fond of those things. This is almost 500 students from 7 different courses that use second chance testing, from STEM, so this is chemistry, mechanical engineering, computer science. Test anxiety. So we have a 6-item Likert scale that we ask about their anxiety, and we ask it twice. So these have questions like, my hands get sweaty when I, take exams, and so it's a 5-point scale, or I have trouble concentrating on the exam because of, such and such. So if we ask them, say, just about your anxiety in general, we get one distribution, and if we ask it saying, for exams that offer second chance testing, we get a different distribution. See, it's clearly shifted to the left. If you do math on this, which is somewhat questionable, you get a 30% reduction in self-reported test anxiety. And from interviews, I think the thing that I'm most excited about is there's students that say, I never took a second chance, but knowing that it was there made me less stressed. And so that's free. Like, we didn't even spend any resources to get that. Students, again, so the fairness, retake tests allowed me to better demonstrate my true test taking ability. Like, students think like, oh, I had a bad day, like, well, if they have a bad day, you can go again. And then again, for the faculty that care about their student evaluations, I feel that faculty that offer retake tests care more about their students than faculty that don't offer retake tests. So if you want students to think you care, even if you don't, run second chance tests. Okay, so putting these two ideas together, this is data from a mechanical engineering course that took 2 paper-based 2-hour midterms and replaced them with 5 50-minute computer-based quizzes. So these paper-based midterms, they were asked to show their work and they got partial credit for showing their work. These computer-based quizzes, they just submitted the answer and they were graded correct or incorrect on the answer, and they had second chances. And what this is showing is their final exam grades. And it was the same final exam, paper-based. So these students actually had a mode disadvantage because you were expected to show your work. And what you see is that the number of D's and F's on that final from the paper-based midterms to the frequent computer, dropped significantly, and that there's a huge shift in the distribution of the students doing better. So I think this is, again, it's a comprehensive final exam. So the frequent testing, along with the incentive to go back and master the things that you didn't know, showed up at the end of the semester with significantly better understanding on average.
We were looking at classes that we were concerned about from a student success perspective. It was always ones that had DFW rates that were in the 30s.
Right.
It was closer to 10%.
Yeah. 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 So these students weren't necessarily getting a D in the class overall because they have other things contributing to the grade, but I think this is a better proxy for what they learned than their actual grade is, because there's a bunch of, things that you don't necessarily trust in the overall grade. Okay, a common thread is more exams means good thing happens. As faculty, running exams is kind of a pain in the behind. So it would be great if we could run unproctored online exams, but sadly we can't. Sadly, some students cheat. And what I'm going to show you is a little bit of data on what I call learning to cheat, which is explained by the fraud triangle theory. So going back to this course that had the exams preceded by, so this proctored exam preceded by the unproctored quiz, what we realized is we created a cheating honeypot. So like, we wanted to, so in the security context is like an unsecured machine that you want people to try to break into so you can learn about the behavior of those people, that we could compare the performance of the students on the same question generator on average, that some of these questions and generators were on both of these. So we could look at how much better the students did on the unproctored version than the proctored version a week later on average. So we had a lot of data, big class, many question generators, so a total of 100,000 data points. We do, again, a giant regression where we're trying to predict the student's score by inferring each student's ability, inferring the difficulty of the questions. And this is the interesting bit, which is how much does taking it in the unproctored setting versus the proctored setting improve your score? And so what we see is if we look at a given student and we plot the distribution of all the students, we see that they're doing somewhere between 0 and 6% better on average on the unproctored version. And notably, this is a week earlier that the question, they're doing better a week earlier in the semester than they are on the proctored assessment, which again, you'd think, okay, that's probably due to cheating. This course's exams are relatively high scoring, and so there's a bit of a ceiling effect. So I think, if you had harder exams, you would see larger benefits. But what's more interesting to me is the benefit change, the advantage grows over time. That if you look at the advantage on exam 0, the mean is about 0, that there's as many students that are doing better on the questions on the exam as on the unproctored quiz. But over time, the distribution moves farther and farther to the right. And so this is this effect that we call learning to cheat, that clearly it's unlikely that this many students are doing this much better a week earlier for any reason other than cheating. And you could say, well, oh, maybe they're really studying hard for the quizzes. Again, the unproctored benefit is going up as the semester goes on, but the studying for the unproctored assessments is going down in that same period. So this is the studying for the proctored exams that's staying roughly level or going up, whereas the studying for the unproctored quizzes is going down. So scores going up, studying going down. Occam's razor says they're probably cheating. Yep. Again, the practice exam generator is how many questions they're attempting. So this is a slightly different metric. This is average number of practice exams they're doing. So here, these students are doing on average 9 practice exams in order to prepare for that. Whereas, for the unproctored quiz, they're doing on average 4. So some students are still doing it seriously, other students are not. And it seems to be more and more students are not. So what's going on? So there's this thing called the fraud triangle theory that I did not invent, and it's not even education specific. So like if you're wondering why people commit fraud on Wall Street, this is the same model that gets used. And there's 3 requirements for fraud to occur. First, there needs to be some perceived pressure, incentive, or motive in our context that students can't earn their desired grade without cheating. Second is there needs to be perceived opportunity. They need to think they can get away with it. Maybe this is because the exam isn't secured, maybe because cheating isn't prosecuted. And then the third thing is one that people don't often think of, but I think is really interesting, is how can I think of myself as a good person even when I'm doing this thing that I know is wrong? Students know that cheating is wrong, but they still do it. And so you need some narrative that helps you tell yourself why you're still a good person. So these narratives are like, everybody's doing it. The professor doesn't care. This class is too hard to succeed in without cheating. And what I think explains that learning to cheat behavior is all of these 3 things are getting stronger as our semester progresses, that the material gets harder, the students, struggle more, so there's more incentive. Students, the more time they spend in a assessment environment, the more they get a sense of like what they can get away with. If you do something new, they're going to be nervous and they're going to be sort of very straight edge, but the more times they go in, they get a chance to sort of case the joint and and also talk to other students. And then the rationalization, again, students talk to each other. And so if some students are cheating, like that gets out and like people know that you can get away with it and everybody's doing it. And so you get more of it. So I think that's exactly sort of what's happened with ChatGPT. So all this data actually is pre-ChatGPT. So the problem is even worse now.
Just curious.
Yeah.
Do you have any data from like the COVID lockdown era? 'Cause I know like
Sort of.
number 3, a lot of the rationalization during lockdown when we had to give online exams.
Yeah, let me come back to that a second after I show you this thing. So this is what we think is the answer, which is our computer-based testing facility. And it's an idea that we want you to steal. So basically, it simultaneously reduces effort while improving its learning potential because we can run frequent and second chance exams. So this is a picture of one of our large labs. This room seats 85 students. We run it 12 hours a day, 7 days a week. So these are actually the students, the people pretending to be students are actually our student proctors. The important things about here is the room is proctored. So we have 2 proctors in each room that check in the students. We have security cameras that are monitoring the room. So if the proctors notice something funny is going on, we go back to the footage from the security cameras and we can know for sure that, were they behaving normally or did they pull out a cell phone or whatnot? We control these machines. These are institutional machines. So we control what they can access on the internet, what file system they connect to. For our CS majors, I guess for a bunch of our students, the fact that they're on computers is great for CS majors. A, they like to type, and B, they can use compilation and debugging tools on the computer. But even for our engineers, our campus is trying to encourage engineers to use computation as a problem-solving thing. And so, our engineers in mechanical engineering class have access to Python and whatnot, so they can write code to solve the engineering problems on their exams. We also provide calculators. Yeah. So, yep.
Yeah, just logistically, we tie credit hours to the amount of time, classroom time is.
Yep.
Do you take this into account or do you?
Yeah, so our campus requires us to give back time if we have out of class exams. They don't really, there's a little bit of funny math that goes on. So, when I give a 50-minute exam in the CBTF, I mentally do the calculation of like, oh, it's really a 25-minute exam that I'm being generous about giving them 50 minutes to do because I don't want time to be a constraint. And so for every 2 25 midterms, I take away 1 50-minute class period. And for the second chance tests, since they're optional, I don't take away any time. I've never had a student complain about this. Yeah.
Did you say the midterms are 25 minutes long?
So we give them, so most of the exams in our CBTF are 50-minute exams. We basically run on the same hour schedule that the university runs on. And we strongly encourage people to do more 50-minute exams. There's some people that are like, oh, I've always done 2-hour exams. And so we do support 1 hour and 50-minute things, but they create problems in a number of ways that in the middle of the exams, a bunch of students are going to get up and leave. And so that's a disturbance for those students. But it also creates a pig in the python in that if you have a bunch of big exams in a particular week, it's hard to have enough capacity. So by having more smaller exams throughout the semester, we can support more classes in the same space. Yeah. Yeah, I'll get to that. Let me get to the 4 main reasons why I think this works. So the first is sophisticated problems. So we didn't want to dumb down our course by shifting it to computers. So at the time, Canvas is like, you can ask these 4 kinds of questions. And I'm like, I don't want to ask any of those questions. And so my colleague built a tool called PrairieLearn. This is open source software, which I believe is the most flexible question asking platform in the universe. Basically, you can build complex, authentic, auto-graded questions, not multiple choice. This is just one example of a question in my course. This one's not even particularly interesting. I can show you a couple examples. I give you a MIPS instruction. I give you a picture of a MIPS processor. I ask you to set all the control signals for it. We can do programming things. We can do symbolic math. We can do, drawing questions where this is one where they engineers have to draw a free body diagram of a system and we can grade that. So thing one is complicated problems that are interesting. And I'll get back to your question about, what about theory courses? The second thing is writing question generators. And I already kind of, harped on this, but the thing is like this question, I randomize what the instruction is. And so they have to set a different set of control signals. So I just wrote a piece of code that given an instruction knows how to set the control signal so it can check the student's answer. So the key thing is that you write this question once and then you never have to write it again. And so that's really great. And that means we can give them to on homework, practice exams and across semesters. And again, I don't worry about, for the most part, exam security, keeping my questions secret. Increasingly, this means people are also willing to share question generators, that if my exam trustworthiness is not dependent on keeping my questions secret, I'm willing to send my questions to my faculty colleague in another university, which it.
And is this an LTI, like you can use this in?
Yeah, so it does use, it does connect to Canvas through LTI.
What's LTI?
It's how Canvas talks to other tools.
So you can set it up so it reports the grade back to your Canvas.
Yeah, Canvas gradebook. I hate Canvas's gradebook, so I don't do that, but you can. So people do. I personally don't know how to do it because like I hate Canvas, but I use it for like messaging. Yep.
Firewall environment.
Yeah.
So my courses, I specifically students how to get around those things. So why do you need it, first of all? Also, what happens if they somehow get around?
Why do I need it? So that I need it so that I can't use ChatGPT during my exams. So, and I don't think any students got around it. So basically these computers go through a networking box that just says that only whitelists certain IP addresses. And we have a lot of CS majors taking exams and I have not heard of anybody getting around that. I think that's a pretty straightforward.
And before ChatGPT, there was just chat. Like
Yeah. Just talking to students or looking up on Stack Overflow or whatnot, Yeah. And so, so again, we've been doing this for 20 years and it's a constant security, we don't allow students to bring scratch paper in, but we provide them scratch paper in the facility. And so initially we started with white scratch paper. And then students started trying to bring in pieces of paper and pretend that they were things that they wrote while they were there. So we shifted to colored scratch paper. And then there all of a sudden became a market for colored scratch paper on our campus. And so now we randomize what color of scratch paper we use every hour. And so, again, this is that learning to cheat. The more time they spend in an environment, the more things they try to get away with. And so, for people interested here in piloting, the good news is that you can get away with not very secure environment for a little while you're just sort of like figuring it out. But like after a couple semesters, then you have to like figure how to do it for real.
And by the way, these get used as labs for other
No.
activities.
This is purely testing. This is the most utilized space on campus because we're literally running 12 hours a day, 7 days a week at 70% capacity. So for arguing to the administration, like this is a very effective use of space. Space is really hard to get on campus. I understand that. But so when we first started, we time multiplexed with, they ran lab sections in the afternoon and we used it for testing in the morning. But now we have 4 rooms of this, total of about 250 seats that run, 7 days a week, 12 hours a day.
Testing in all classes.
All classes that choose to do it. Anybody who wants to, we now have enough capacity that people, I'll show you some data on that, but it's a lot of lower level STEM classes, but there's like a health science class. So the third principle is asynchronous exams, and this is the one that makes people nervous usually. It's a big hassle trying to get everybody in the same place at the same time to do the same thing. And so what we say is don't try. That we give students a 3 or 4 day window. It's usually 3 days, it's 4 days if it goes over a weekend. And basically what it means is there's no conflict exams. The students pick a time in that window that goes around their conflicts. And so I no longer have to run conflict exams. And if a student gets sick, if a student gets mono during that whole, 3 day window, I just basically make it an 11-day window and it's a 1 round trip email. They say, hey, I'm sick. Here's my documentation. I say, seems fine. Extend the window. Great. You schedule, now in this new window. And then, when the exam's done, I pick it up.
And
It's on them to schedule a time.
Yeah, and like 1% of them will fail to show up at the right time, and so we basically just cancel and reschedule them again. So we try to run the facility to about 70% capacity, so there's slot for, there's no student that has to take an exam at a particular time, that they have a bunch of flexibility, and to deal with the fact that like if something bad happens, you know, we can reschedule them, you know, if we need to. We try to discourage it. We've joked about like charging them a fee to like fund the CBTF every time like they miss a reservation, but we've never done that. It also enables a large class to use a relatively small computer lab. Our CS1 for majors ran last fall at 1,150 students. They ran weekly quizzes in that course. That's taught by one teaching faculty member, that whole course. And a big piece of that is them being able to do assessment in a way that doesn't use their course resources. Yep. Yeah, so I think there's pedagogical value to writing out that note sheet. So I lament the loss of it. But the thing is, we can't, you know, we have about 45 different classes that are using the facility throughout the semester, and we can't do different things for different classes. So some people don't want you to bring in stuff. Some people do. We have to provide sort of the least common denominator, which is not bringing stuff in. So you can provide through the, you know, through PrairieLearn, for example, whatever formula sheets you want. In my intro to programming class, I basically downloaded the whole Python documentation and I provide it to them as part of the exam so they can look at stuff. I lament that loss, but it's sort of we have to do sort of it's like Costco. You know, Costco, you only can buy certain things. If you don't want those things, you go shop somewhere else. You know, not everybody on campus uses us for their exams because we don't do the thing that they want, and that's fine. But for the people that want, what we can give them, you know, they're really happy.
So you say you have all the Python documentation, all these machines?
Through the thing that's serving their exam, there's a link that they can click, and so yeah. So again, it's been whitelisted. Our PrairieLearn server has been whitelisted, so anything I put on the PrairieLearn server, they can have access. Right. Yeah, they're just linked from the exam. The fourth thing is centralizing and professionalizing the proctoring. So I believe it's inefficient and expensive to have faculties and TAs proctor. These are like high skill people. Proctoring is low skill labor. Instead, we offer proctoring as a service. That means you and your TAs can spend more time interacting with your students rather than proctoring and in many cases grading the exam. And so with the automated exam scheduling and grading, our exams are basically free once you have the exam content. That's the hard part. And that sort of is what enables frequent testing and second chance testing. As long as, so there are some classes that will do like 90% auto graded and 10% manually graded. And they just decided that's the thing that they want. And so again, you can choose to do that. You don't have to do one thing or the other. Yep.
In these labs, you don't have proctors that are content experts.
True. And my claim is that if you need a content expert for students to take your exam is broken. And I think it's also an equity issue that some students know to ask and other students don't. And so the ones that know to ask will get an advantage. So I think it's actually a feature that our proctors don't know. If there is a problem on the exam, so occasionally we will put, you know, back in the day when I was writing a lot of new questions, occasionally in spite of our testing, there would be a buggy question that leaked through. There's a really nice thing that happens that because we're running our exams asynchronously, the strongest students are the ones that take it first because they're least scared of it. And there's a button in PrairieLearn that says report a bug in this question, and they can often articulate exactly what's wrong with the question because they're your best students. And so you're crowdsourcing, but it's even better than that, if you monitor your exam in those first couple hours, the bugs will be found, you can fix them, and then like 98% of the students will never see the bugs. You give this first couple students 100% on the question because they probably would have gotten 100 on it anyway because they're the best students. And most of the students never see the bugs. So you don't have that problem where you're running exams in multiple rooms and your TAs are having to call each other on the phone being like, what are we doing about this thing? And then different students get told different things about it. Like, so that's really good. We handle most of the testing accommodations on campus. Distraction reduced, we handle by, on our campus, you have to block their peripheral vision, and we provide them noise canceling headphones so that they don't have audio distractions. Extra time, we just let them sit in the chair longer. Other things, basically at the beginning of the semester, the student provides their documentation to the CBTF, and they configure the scheduler so that it only offers them reservations that can meet their accommodations. So this is huge. Students prefer taking their exams in the CBTF, because our hours are better. We run from 10 a.m. to 10 p.m. 7 days a week. So, and they also feel less stigmatized because they're taking the exam where everybody else is taking their exams. They don't have to go some weird place on campus and do things. Again, it changes the way we test. So here's some data. It started in 2014 fall with just my course. And then over time, it's just every semester, 2 to 4 courses have sort of joined on. And we have courses from Aero Bio-E, Civil and Environmental Engineering, Chemistry, CS is this big chunk, ECE, Material Science, MECE. The guy who wrote PrairieLearn is a mechanical engineer, actually is an applied mathematician who sits with mechanical engineer physics, stats. This is 2019, so it's kind of old data, but basically, so now we have 4 CBTFs. Last semester, we ran 100,000 exams for more than 9,000 unique students. We have, around 45 of our largest STEM, mostly STEM lower level courses using the facility. It works. We give faculty no incentive. We don't tell anybody they have to use it, that it's all people that are electing to use it. And when that happens, there's 90% repeat usage, that basically many people are like, I will never leave Illinois because I don't want to go to a place that doesn't have a testing center. So we're trying to change that so that you can see all our faculty. But in particular, when we started this by funding it with an internal grant from our College of Engineering that lasted 3 years. And at the end of that 3 years, we needed to convince the administration to make this a full-time thing. And at that time, we did a survey to faculty and we asked them, would you be willing to give up one of your graduate TAs in order to continue to use the facility? And more than half of the faculty said yes to that. And so I think that was, so we haven't taken away those TAs, but I think we could, because we're offloading so much of the work that the class has to do. Instead, we've just repurposed those TAs to have more interactions, and classes are reintroducing open-ended projects and things that they got rid of when their enrollments went up. We did some math a while ago and found that it was around between $1 to $2 per exam, counting the scheduling, proctoring, and grading effort. Most of the expense is proctoring, but that is surprisingly close to the cost of printing paper exams per exam per student.
So you're not taking into account the overhead of developing exams, right?
Yeah, and so we're increasingly, so large upfront costs for developing content. We're trying to make it really easy for people to share content because, again, there's no reason that everybody needs to develop their own question generators. My colleague at Berkeley, Dan Garcia, says, okay, I've written a question where, given an IEEE floating point representation, what is the number that this represents? And he's like, well, it does every bit pattern, so you can't really make this question any better. And there's no reason that anybody else needs to ever write this question again. They should just use the one that I wrote, And I think that's the mindset of the value we're providing is not in our exam questions. It's all the things that we do to prepare our students to do these exam questions. So why aren't we just sharing them when your exam trustworthiness doesn't depend on secrecy of your questions? So we want to get to the point where there's some giant website where you can say hey, I want a question on X, and there's also all these social media things where people have upvoted questions that they like and whatnot. We're not quite to that point. The system does support sharing questions. So right now, a lot of the question sharing is if you know me, you say, hey, and I give you read access to my GitHub repo, and you can rip whatever you want out of it. The system now supports sharing questions through the system, so I don't actually have to give you permission to my whole repo. I can say oh, I want to share this question in a binary form so you can actually see it, or I can share it in a source form. But you still need to know who to ask to get the questions, and so we have a active user community. Yeah, so maybe it's a good time to sort of transition to.
Before we leave this slide, what's most positive? What's the negative?
Um, I think the only negative that I can think of that's actually substantial. So I think it's important to realize that this does one thing well, and it's not everything that you want to do, and so you should deploy it where it's useful and not where it's not. I think the only potential negative is it now requires you to, if you want to understand how your students are doing, you have to elect into looking at the exams. So it's easy to get detached from how students are doing in your class because everything, like the exams run and students get grades and no human has to be in the loop. And so you're potentially at risk of, in the world where you wrote new exams and this, you had discussions about like, oh, so many students are failing this question because it was really obvious. And you can still see that we give a lot of, per question stats on the exam. So you can see like, oh, this is a thing that the students, this is in PrairieLearn. So you can look at this, but like you have to choose to, and sometimes life is busy for faculty too, and so we may not make those choices.
See an example of what coding.
Coding question, yeah. So
What's the highest level coding class that you? It does sound great for.
So our database class uses this, so they will run questions where they will generate a random database with random tables of different sizes and ask you to do a particular random query on those tables. So in that class, they still have a big open-ended project at the end where they have them build a website with the data system behind it. But for all of the sort of low-level skills that they want the students to develop, they use the CBTF and PrairieLearn for those. And then, again, they have the open-ended project at the end. So this is just a demonstration of what are called workspaces. So PrairieLearn allows you to run an application in a container on AWS and then show that to the students through the web browser. So this is a simple Python programming question where the student work is done in VS Code running inside of PrairieLearn. And so I use this for my Verilog things, and the students do run a Verilog compiler in here, and they can see the waveforms in this thing. But so the key thing is that, if I
Program in here, run it.
multiple files, yeah, and then when they're ready to submit it, and I need to make sure I don't click the close button, stupid Zoom in the way. Then they hit save and grade over here, and that reaches into the container and grabs the associated files, and it runs a bunch of test cases against it. So I only did this test case. So this is a pretty common
Question. Go.
Yeah. Yeah. So on homework, we allow them basically as many attempts as they want. On question generators, they will often get another question. So I'll show you that. So here's a thing where I've given a circuit, give me the Boolean expression. I'm not going to try to answer that. But it will immediately tell me, okay, one solution is such and such. And here I've chosen to link a video of me solving an example one of these. And then they can say, hey, just give me a new variant. And what it'll do is it'll generate a new Boolean expression. And I have a piece of code that knows how, given a Boolean expression, knows how to draw the circuit. So these aren't like stored images, they're being generated programmatically.
But in the real assessment,
they get one question, but they may be able to attempt it multiple times, and you can set the credit for that. So once they run out of attempts, so on this quiz, it's called the quiz. Yeah. This first question pool has these 4 question generators in them. And if they get it right on the first attempt, they get 5 points. If they get it right on the second attempt, they can get up to 2 points. And then after they've done 2 attempts, it will show them the correct answer because they have no more attempts. My theory guy left, but this is a question where in my machine organization class, we introduce finite state machines. And so I'm describing a finite state machine that they should build. So it's what makes a good bracelet. So you have to put on a certain pattern of beads in order for the bracelet to be considered good. And there's a description of the encoding of the input. So when you put a white bead on, you have, 0, 0, and there's rules for what makes a good bracelet. And because PrairieLearn is the most flexible question asking platform in the universe, I can put in a CAD tool here where I can design a finite state machine. And if oops, how do I delete? Well, I guess I'll just change the names.
Some tool that to draw state machines.
Yeah, and it's a tool. And you can label the edges with transitions, and it's not a tool that I wrote. I found somebody's code on the internet for drawing these things. So PrairieLearn lets you use any HTML5 you want as part of a question. I took their code and I modified it so that every time you do an action, it generates a new serialized representation, a string that represents this thing, that when you hit submit, it sends that string to the server, and then the server knows how to unpack that, simulate that finite state machine, run a bunch of tests against it.
I mean, that's awesome. That's tremendous work.
Right. So writing the first question of a given type is a bunch of work. Once you've done that work, then writing, proliferations is pretty easy. And this is exactly why we want to do the sharing is, because it is a lot of work. And, what people typically, what?
Super cool.
Yeah. So it will refuse to grade this because it's not complete. That it says, okay, the output value in the start state was left blank. So that's just one example of what was bad about this. So if I go ahead and make this complete, to label this, we'll call that A, in which case I need a back edge for B prime. I think that's complete. So if I now say save and grade, oh. What did I do wrong? That's the start. That indicates what the start state is. Multiple state transitions for A1, B0. Oh. Yeah, this has to be, oh no.
It's okay.
Yeah, so basically what it'll do is it will give me an example. This question has been coded so that if it tests your thing and it's not correct, it'll say, okay, what fraction of the test passed or failed? And it'll give you an example of a failing test. So on an exam, the student can then take that feedback, modify their thing, and they'll get fewer points, the number of attempts it takes them, but it's a way of granting partial credit in the presence of using auto grading.
I gotta go.
Yep.
This is awesome. Are you gonna post these slides?
Yeah, so I think the talk's being recorded, and I can share the slides also. Cool.
Yeah, that's great. I think we'll probably have to do later.
Cool. Yeah, I'll be here for a little while. Yep.
So I know you said keep it's a generator listing, so clearly there's no fixed answer being stored anywhere. So
Oh, yeah. So how does this work?
yeah, I'm curious because you said GitHub. My worry is that I'm on GitHub.
Sorry, what's your concern about GitHub?
So my concern is that GitHub will share the entirety of the material as training material for their
So I can comment on this actually. I had since we use GitHub for both the classes that I teach, the student asked me this, right? Like, is my code, since I'm submitting my assignments on GitHub, is that gonna be used in training models, Copilot, whatnot? And so I wanted to look into this, and I mean, at this point, Microsoft promises that anything that's private, they only use public repos to train their models. And if you think about it further, I mean, that would be a big deal if they started to train on private, right? Because companies' entire intellectual properties live in private repos. So if they started leaking algorithms,
Right.
companies,
Or even if they just had allowed Microsoft engineers to go in and look at your repos, like they would get destroyed. So I kind of believe that, you know, like the thing is like, I don't actually care because again, the trustworthiness of my exams is not because I'm keeping the questions secret. That
And the answer is not, it's like, you have.
Yeah, so basically this is what the generator for that digital logic question is. That basically I have a piece of code that knows how to generate a Boolean expression. I store that. I have a piece of code that given a Boolean expression knows how to draw a circuit, which draws the picture. So we generate that. I just am storing the generated expression as in an object that every time a student says, give me a new question, it calls this generate function and it passes an object, and I get to put things in that object that I can use to either render the student to say, you know, what the problem is, or in this case, this is part of the correct answer. I give the Boolean expression, but because there's multiple Boolean expressions that encode the same thing, I generate the truth table because the truth table is unique from both what the student submitted, and you know, if they submit some garbage, I'm going to get an exception. So I give them a 0 and I say, hey, your submitted answer contains some unacceptable characters. But then I can also generate the truth table for the correct answer that I generated. And then I just compare, are these the same thing? And if they are, they get points. If they aren't, they don't get points. So this gives you an idea of sort of the back end logic. And then on the other piece is the presentation piece, which basically is a glorified piece of HTML where, you know, a lot of this stuff just looks like HTML, and some of it, you know, it's a template. So some of those things, that correct answers.expression is that thing I put in the data object. And then there's just some PL specific, PrairieLearn specific tags. For example, we've built what's called an element for students giving a string answer. So there's a bunch of things that people do over and over again. For example, like, you know, if you have an engineering calculation, it might ask for a numerical answer where you want to do plus or minus some, you know, tolerance, or a symbolic answer. So these things that people do over and over again, we've encapsulated into what we call elements. So if I just want students to give me a string, this thing will check to make sure that the thing is actually a string, or like the numeric one will check to make sure that there's only numbers and punctuation in it. So it'll turn it away. Similarly, when I have this question, there's 3 parts to the PrairieLearn presentation. There's the presenting the problem to the student. There's the submission part. So this is as when I submitted, I said X, and if I submit again, you know, every time I submit, we record it, so I could go back and look at all my submissions and see how many points I got on each. And then there's the correct answer panel. And so PrairieLearn follows don't repeat yourself. So we use one document to produce all 3 of those views. And so if you have stuff that you only want to show up in that question panel, you wrap it in these tags. So this part didn't show up in the other 2 panels, whereas this input string showed up in all 3. And then this stuff only showed up in the answer panel, the correct answer panel. Again, like with very little, you know, we're using standard technologies, Python and HTML5, which makes it mean that you can steal a bunch of stuff on the web and boom, you've got questions. I have one of my colleagues who's a roboticist stole some HTML5 that allows you to rotate and translate a robot in 3D space. And he says, okay, here is a rotation and a translation matrix. Manipulate the robot so that it's in the correct position and orientation. And like, he wrote that question with, you know, remarkably quickly, given how complicated it is, because he could steal stuff and use it in his questions. All right. I think that's most of what.
I think that is still, that's really good though, because even this year, you know, being tired of all of that, whether there any algorithms, they're very limited logical ability. Extract answers from fight, so this is
right. Yeah, and again, I literally don't care. My belief is if you have enough questions, you could put them out in the public domain and it wouldn't change your exam scores, because, you know, if there's near infinite number of questions, that you just need to learn the material. And if you learn the material, that's the thing that we want to discuss anyway. So yeah, automate things that improve with automation, allocate humans to do the things that don't get better with automation. Yeah. You want a question for online?
Insatiate similar facilities at other institutions.
Yeah, so we have a bunch of resources. Like this is an idea we've been trying to give away as much as possible. We have a bunch of resources that include how to set, like what we can think of just how to set one up. Some letters that my colleague Armando Fox at Berkeley wrote to his administration trying to convince them to resource this. We are happy to talk. So PrairieLearn has a weekly Zoom office hour that our CBTF coordinator attends. And so if, you know, like, again, we're trying to be as helpful as possible so that, because to us, this is just kind of a no-brainer. And like, we recognize that starting one requires bringing faculty and administrators and IT people together. And so it's kind of a pain to get started. And so we're trying to be as helpful as possible in doing that. So if you have any questions, either reach out to me or, and you know, yeah, I don't know if you want to be the contact person on campus for the moment. Yeah, that as far as future research studies that I would love to have more, like many of us use the CBTF and never want to go back. And so that makes it hard to do studies where we compare pre-CBTF to post-CBTF. But like, if you're in a position where you're currently doing a thing now and you may later have a computer-based testing facility, you know, collecting data now and then comparing it to data later would be fabulous. And I would love to help collaborate on those papers for anybody who is interested in that. And in particular, the thing that we haven't done a lot of is looking at longitudinally, like success in later classes based on, you know, adoption of these techniques. And again, none of us want to go back to the way things were to do those studies.
Please join me in thanking our speaker.